Hey everyone, it's Justin again. In the last video, you learned how to interpret the shape and features of quadratic graphs, also known as parabolas. But usually we use functions in their graphs because we have a specific question we want to answer. So in this video, we're going to learn how to find those answers by using the information hidden in quadratic graphs. By the end of this lesson, you will be able to use quadratic graphs to answer questions based on the given context. This is an extension of our previous lesson, so we're just going to jump right into some examples. First, a couple of easy ones, just to get you warmed up, and then a harder one to really get your brain moving. So here's one of the graphs we saw in our last lesson. Graph parabolas can give you a lot of information at once, but that's only helpful if you know what piece of information answers your burning question. For instance, how long did it take for this drone to reach the ground? It helps to read graphs like these like a story. The drone takes off from the roof at a height of 9 feet, flies up to a maximum height of 12 feet, and then comes down until it's 0 feet high, meaning on the ground, after 9 seconds. From the time it took off to the time it landed, there was a total of 9 seconds. Some scenarios like this one can't really be told as a story because time isn't one of the things we're measuring on the graph. In this scenario, we don't need to know when something happens, we just want to know what decision is best. So instead of looking at it as a story, let's look at it as a list of causes and effects. What price will generate the most profit? If Maria gives away her shirts for free, there's going to be plenty of people who want them, but she won't make any profit. If she charges $12, nobody will want to buy from her, and she won't make a profit there either. But there are other points where she will make money. If she only charges $2 per shirt, she can make $320. At $4 per shirt, her profit improves to $515. Each point on here gives us another cause and effect pairing. With this data, we can answer the question, how much should she charge to make the most profit? And according to our cause and effect chart, her profit maxes out right here, where she charges $6 per shirt. Now, did we need to create a whole chart to answer this question? Not really, because all of that information is readily available in the graph. The point where the parabola reaches its highest profit is right here, where the price of a shirt is $6. Be careful though, because some questions are trickier than others. Here we have another story-based scenario because it's over time. Darius is out $360 when he opens his business, and then he continues losing money until he's down $400. Then he slowly starts gaining money back until he's finally broke even a little over 8 months in, then starts earning more money than he started with. The problem is, none of these events answer this question. We have to dig deeper. The question is asking how long did it take? So we know the answer will be the number of months or the difference in x coordinates between 2 points. Darius's lowest point and when he earns half that money back. First, when did he hit his lowest point? Well, that's easy. That's where the minimum of the parabola is, here at the vertex, 2 months after the business opened. And from there, we want to know how long until he earned half of it back. At his low point, he was down $400, so half of that would be $200, which is how much he was still out at this point, about 6.5 months after opening. So if he hit his lowest point 2 months in and made back half his money 6.5 months in, how long did it take to earn back half his money? The time between those 2 points was about 4.5 months. Even though this question was harder, the necessary information was still on the graph. We just had to find it. Graphs can give you loads of information, but they don't just appear out of nowhere. They're created from algebraic functions. Linear graphs come from linear functions, exponential graphs come from exponential functions, and parabolas come from quadratic functions. So, in the next lesson, you're going to begin learning how to graph these quadratic functions yourself. See you then.